When we talk about slope, this allows us to talk about two very common types of lines when we're comparing lines. And you may have heard these terms before. Parallel lines and perpendicular. Right, and as we proceed, and the more math classes you take, these will come up more and more often. And we might already have a characterization of parallel lines and perpendicular lines from a geometric standpoint. Right, if I asked you to describe parallel lines, or if I asked you, are these two lines parallel? Right, what you're probably looking for, and which would be a perfectly good working definition of parallel lines, would be two lines on the same plane and never cross. We know parallel lines when we see them. I only say on the same plane because it's going to have to be on the board in some two-dimensional space. In 3 dimensions, I can have two lines that don't cross, that are not parallel. Right? But in 2 dimensions, we know parallel lines when we see them. Never going to cross. All right. Perpendicular lines, on the other hand, might have a harder time defining geometrically, but you might know them when you see them as well. All right, so geometric definition would be two lines that cross at 90-degree angles, right, or right angles. Right, so you might see perpendicular lines. Think of it as like an intersection between two roads, and we let them know that there's a 90-degree angle by putting a little box there. Right, so perpendicular lines, starkly different from parallel lines, but hopefully we have this background knowledge. Maybe not the definitions, but we know them when we see them. And what does that mean for us in terms of slope? We can actually characterize these and define these, right, with our idea of slope. Right, parallel lines, if two lines are never going to cross, parallel lines, they have the exact same slope. Right, that should make sense if this line is going up 3 and over 2. Right, this line better be going up 3 and over 2 and rising and running at the same rate, so they don't hit each other. If they were going at different rates and different rises and different runs, well, then they would eventually cross. If this one was going up more than this one was, eventually they would run into each other, but they're going in the same direction. So think of rise and run as our directions. Right, so they have the same slope. Right, perpendicular lines, on the other hand, right, these are exactly opposite slopes. So what I mean by that, I mean opposite in two ways. Right, slopes of perpendicular lines are opposite reciprocals. All right, so what I mean by that, like opposite in two ways, right? Well, they're opposite in terms of they're reciprocals of each other. So if I had one line that had a slope of 2 over 3, its perpendicular line would have to have a slope of 3 over 2. So you take the fraction and flip it upside down. So that's one way that it's opposite. All right, but not only that, it has to be opposite in terms of sign. So if I have a positive slope, its perpendicular line would have a negative slope. So two types of opposite. We're going to take any slope that we have, any rise over run, we'll flip it upside down, and we'll change the sign. If it's positive, it'll now be negative. If it was negative, it'll now be positive. So for example, I find a parallel and perpendicular slopes of a line with a slope of, let's say our line has a slope of -4/5. Okay, so if we want to find the parallel slope, well, that's easy enough, right? Parallel lines have the exact same slope. So if my line has a slope of -4/5, any parallel line better have the exact same slope. Perpendicular, here we have to do a little bit of work. All right, perpendicular lines, right? They have opposite slopes. So if my original line has a slope of -4/5, right? Since this is negative, my perpendicular slope better be positive. Right? Since this is 4/5, my perpendicular slope better be the opposite or the reciprocal and be 5/4. Right? Pretty easy once we know what to look for and know what to do. Just to point out one other situation, if I had, this is my first example, this is my second example. All right, if I had a slope of 3, well, obviously a parallel line better be a slope of 3 as well. Right. And the perpendicular line, right, remember, if we're dealing with a whole number, we can always think of it as a fraction. So, right, if we have a slope of 3, think of it as 3/1, rise over run. Right, so our parallel line would have a slope of 3/1. And our perpendicular slope, now we can figure this out. This is positive, so perpendicular must be negative. And 3/1 reciprocal 1/3. So we can do it with whole numbers or with fractions, because we can just think of any whole number as a fraction and find the parallel and perpendicular slopes. All right, there we have it.